The earth beneath our feet, often taken for granted as a symbol of stability, recently sent a stark reminder of its immense power to the residents of Northern California. A series of earthquakes, rippling through the region like a wave, has once again brought the ever-present danger of seismic activity into sharp focus. The tremors, though not as devastating as the historic earthquakes that have shaped the region's landscape, have served as a wake-up call, prompting renewed discussions on preparedness and the potential for a larger event. The San Andreas Fault, a slumbering giant running the length of California, is never far from the minds of those who live in its shadow. The recent swarm of earthquakes, clustered near the fault line, has reignited concerns about the fault's potential to unleash a major earthquake. Scientists and geologists are closely monitoring the situation, analyzing data and historical patterns, in an attempt to understand the significance of this recent activity. The Earth's crust, a complex and ever-shifting mosaic, holds the answers, and scientists are working tirelessly to decipher its cryptic messages. The recent earthquake swarm, a series of smaller earthquakes occurring in close temporal and spatial proximity, has rattled nerves and captured the attention of seismologists. The earthquakes, ranging in magnitude from 3.0 to 4.5, have been centered near a specific location near the San Andreas Fault, a region known for its complex network of fault lines. The depths of these earthquakes, varying from 5 to 15 kilometers below the surface, place them within the Earth's crust, where tectonic plates grind against each other, releasing tremendous amounts of energy. The proximity of these earthquakes to the San Andreas Fault, a major tectonic plate boundary, is a cause for concern. The San Andreas Fault, stretching over 800 miles along the coast of California, is the boundary between the Pacific Plate and the North American Plate. These plates are constantly in motion, moving horizontally past each other at a rate of about 2 inches per year. This movement, though seemingly slow, creates immense stress along the fault, which is periodically released in the form of earthquakes. Understanding the forces at play deep beneath the Earth's surface is crucial for interpreting the recent seismic activity in Northern California. The leading theory behind the earthquake swarm centers around the concept of tectonic stress. The Earth's lithosphere, its outermost shell, is broken into a series of tectonic plates that are constantly in motion. These plates interact with each other at their boundaries, creating zones of intense stress and strain. Another potential contributing factor to the recent earthquake swarm is the phenomenon of fluid migration. Deep within the Earth's crust, fluids, often superheated water, are trapped within rock formations. These fluids can migrate through fractures and pore spaces, altering the stress conditions within the crust. Changes in fluid pressure can act as a trigger for earthquakes, particularly in areas already experiencing high levels of tectonic stress. Echoes of the past, drawing parallels to the 1906 San Francisco earthquake. The recent earthquake swarm in Northern California has inevitably drawn comparisons to the devastating 1906 San Francisco earthquake, a defining moment in the region's history. The 1906 earthquake, with an estimated magnitude of 7.9, ruptured a 296-mile segment of the San Andreas Fault, unleashing unimaginable destruction upon San Francisco and surrounding areas. The earthquake and subsequent fires reshaped the city, leaving behind a legacy of resilience and a heightened awareness of seismic risk. While the recent earthquakes pale in comparison to the 1906 event, they serve as a reminder of the ever-present seismic hazard in the region. The San Andreas Fault, capable of producing earthquakes exceeding magnitude 8.0, poses a significant threat to the millions of people living in its vicinity. The 1906 earthquake, though a catastrophic event, provided invaluable insights into the behavior of the fault and the potential consequences of a major earthquake. Preparedness is key implications for Bay Area residents. The recent earthquake swarm in Northern California underscores the importance of preparedness for residents of the Bay Area. Living in earthquake country requires a proactive approach to mitigating risk and ensuring personal safety. Developing a family emergency plan, securing heavy objects, and having a disaster supply kit are essential steps in preparing for the unexpected. Local authorities and emergency response organizations play a crucial role in educating the public and ensuring community resilience. Public awareness campaigns, earthquake drills, and building codes designed to withstand seismic events are all part of a comprehensive approach to earthquake preparedness. By working together, individuals, communities, and government agencies can minimize the impact of future earthquakes. The unpredictable Earth, embracing uncertainty and ongoing monitoring. While the recent earthquake swarm in Northern California has raised concerns, it is important to remember that earthquakes are inherently unpredictable. Scientists can assess risk and identify areas of heightened seismic activity, but predicting the exact time, location, and magnitude of an earthquake remains an elusive goal. The Earth's crust, a complex and dynamic system, continues to hold many mysteries. Despite the inherent uncertainty, ongoing monitoring and research efforts are crucial for understanding earthquake behavior and improving our ability to mitigate risk. Seismic networks, GPS stations, and advanced computer models provide valuable data that help scientists unravel the complexities of fault systems and earthquake mechanics. By embracing uncertainty and investing in scientific advancement, we can strive to create a safer and more resilient future for those living in earthquake-prone regions.